We're giving a talk about Ubuntu 14.04 long-term something. We're giving a talk about, not even that one works, sorry. We're giving a talk on subtitling, subtitling videos that are being recorded back there, for example. We are presenting work from a student project at Hamburg University in the computer science department. We tried to convince our students to present, but they were afraid this would be too late or too many people or something. So there's just one sitting over there, Florian. Hey, applause. Florian is there. So Florian is studying computer science towards his bachelor degree, and together with five other students, they are working on producing subtitles, or well, producing subtitles semi-automatically for C3 videos. That's the database that we selected for this task because it's freely available. Thank you very much to that. But of course, what we're going to do also works similarly well for other videos, hopefully. We haven't tried it yet. So what we did was we looked at last year's videos, which were transcribed, most of them, or many of them at least. So we have the transcriptions, and for subtitling, you need more than just the transcriptions. That is more than just the text. You also want the timing information for that text. So you want to be able, in your favorite video player, to load in, for example, SRT file. That seems to be a data format for that. And use and click that in your favorite video player, and then you see these subtitles, or maybe on a braille on a braille display, if you can't see, or visually if you can't hear. So I'm kind of lost now. No, I'm fine. We got the transcription. So why do we want transcriptions? Why not just use speech recognition? It turns out that speech recognition is not very good. Hey! Yay! Oh. And now I'm very glad that I will hand over to Arne for all the difficult parts of the talk.
Just waiting for the...
But we're almost there anyway, right? That's good enough. I mean, don't break it anymore.
Yeah, I don't care.
The other way around, please.
Maybe do whatever. I think we already had this.
The switching knob doesn't work? That's funny. It is funny, isn't it? Okay. So this computer has a demo prepared. We're looking into whether that's going to work or not. So it's unlikely.
Please, we had at least some slides. Okay.
Okay, Okay. All right, so up to Arne.
So, hi. So this is our group. I think you've already seen Timo. This is Wolfgang, that is me, and Jonathan, Paul, Florian, Tim, and Faiz couldn't be on the photo because I think he had to move on that day. So we had, I wasn't able to listen. What did you already say that? No. Okay, so what we want to do is generate subtitles from transcription. We need to align them, chunk them into subtitles, and export them into whatever format we want to have afterwards. And our secondary goal is acquiring speech data. Because as a university, we usually don't have access to a huge amount of data. That's the main difference between, huge global players like Google, who can just tape everything you say into your phone. For example, if you are Apple, if you use Siri or something like that, they can actually do that to enhance their performance, and we don't have access to that, unfortunately. So free data is necessary to actually have free software speech programs, speech recognition programs. So, you already went into that a bit. If you try to do speech recognition, you really need to do a lot of stuff. You need to know about the world as a whole. You need to know about what is the context of, well, what I'm talking about right now. And you can all do that in your brain because it's so, well, powerful and optimized for that, but the computer cannot really do all that right now. They usually base their computation on word sequence probabilities. That means we have a large corpus of data which says, well, this has been said, I don't know, 1 million times, and so this is much more likely than something else that has only been observed once. And the problem here is that all of you use weird words in weird contexts, and then the speech recognition just gives up and says, well, I don't know. And to show you that is a really hard problem, maybe you've been to the talk yesterday where Jacob Appelbaum said, oh no, I have to remember it, GNU-PG has safety faults. And what was transcribed live by a human was GNU-PG has safety faults. And what he intended to say was GNU-PG has safe defaults. And that makes a difference. And so that shows that even for humans, when they are under time pressure to actually type stuff in, they will miss things. For example, that he said before that it is good to use GNU-PG. And therefore, we see that speech technology is bad at understanding what humans want to say, and Timo will talk about that in detail. And I can sit down.
Yeah, you can sit down. Oh, now there is no preview anymore. Fine. I was wondering why you were standing here. As Anna said, speech technology is bad at understanding what humans want to say, so that is a problem. So what we tried, or what we figured out, was that humans are at least relatively good at transcribing speech, apart from that example that Anna just presented. But then going from these transcriptions to subtitles is still a major issue. So this is a screenshot I took earlier today from the Amara transcription interface, which is really good at the job, but the complexity of the interface is somehow clear. I think that it's not really easy to figure out what to do. You really have to figure out how to do that, and it's really hard to build a very good interface for this task of putting the timings onto like putting the timings on the text, figuring out what was spoken when. So it's really hard to build a good interface, and I think it's hard to build an interface because it's such an unnatural task to humans. We never do this in our everyday lives. We never figure out when something was spoken. We just know what was spoken. So even if we try to improve user experience for this Amara interface, that wouldn't solve the underlying problem that humans aren't made for this. Humans are made for understanding, maybe for note-taking, but certainly not for subtitling. So our idea here was to have the computer solve the unnatural part of the task and the humans the natural part of the task. Yeah, I got all that already. The idea. Okay, the idea. What happens is a kind of pipeline that is very similar to what speech recognition does. We go from the transcribed text and have to normalize things because as people transcribe, they naturally type things like 431 before Christ, or it might even say ante domini if we're unlucky. But they'll certainly not say 431 B period C period, unlikely at least. Then we have to go from the normalized text that we've got into more like a sequence of speech sounds, like a f or r, what did I say, 400? F or something like that, right? A sequence. And of course, I here write most likely pronunciation. There may be multiple variants that we want to track. And then we want to figure out, of course, when we have this sequence of speech sounds, how does this align with the acoustic waveform that we've got up here? That doesn't happen magically, but it's a learned model. It's learned from lots of data, as Arne was implying earlier, data that is severely lacking when you're working at a university, that we need in order to have good models of how speech is being spoken, of what speech sounds actually sound like. And if we have that, then we get a pretty decent timing information for every word, hopefully. That's our goal. However, if we just follow this standard approach of figuring out things one after the other, and then doing one big search over that, this isn't robust, because this search that we have to take on with like all the different timing variations that could come up is just too large. So what you do in speech recognition in general is you don't do a full complete search, but you do a beam search. And in our case, what we notice is that the correct solution always falls off the beam. So if you're lucky, it may work on very short stretches, like 1 or 2 utterances in a row. It may also work if you have very distinctly, clearly spoken text. So what we tried in a different experiment was looking at spoken Wikipedia data, where we have the article and the text, and people really try hard to speak exactly those words that are in the article. But as we noticed earlier, transcriptions at C3 are just, they have to be done in almost real time, so it doesn't work as well. The approach that we use, it's not our own, we just used it, is to stick with the fact that people say more or less what's in the transcription. There are some stretches of speech that are not transcribed. This actually happens a lot for data at C3, it appears. And also there are transcribed words that are not spoken, so people just type anything and it just happens not to be in the talk. It's quite funny to look at the data. We all believe it's really nice, but it's not perfect. So what we do is we actually do this word sequence modeling that Arne was talking about earlier, but not on like random or huge amounts of text, but only on the full transcription that we got. And then we do speech recognition on the full thing and try to find landmarks where we have a correspondence between the recognition result that we get with this kind of like very specific speech recognizer and the original transcription that we have. And then we iterate over that in a divide and conquer approach. So after that, we look at the stretches between landmarks, trying to narrow it down as much as possible so that only those few bits and pieces remain that we can't align to each other. There is one problem that it's not very fast. It's only running at about 1/8 of real time. So if you've got a 1-hour keynote, that will take overnight, which is quite long in my opinion. So it's not real time anyway. This gives us, this step will give us alignment. So we know for every word, the timing where it's been in the talk. However, we want subtitles, not word-by-word alignments. And with that, I hand off to Arne for the next bit of the talk.
Okay, so how do we get from those aligned words to actual subtitles? If you look at subtitles, that's maybe more complex than you might think, because you have limited space on the screen, so you cannot say, well, I just put one sentence there, because sentences tend to be really long, especially in talks like this talk. So people really go on and go on and go on, and then they say and then you have a really long sentence. The reading performance of the person who's reading the subtitle later on is also limited. So you have to take into account what can be read. And so we need to break up those sentences into shorter chunks. And they must be somehow meaningful. And we can see that simple heuristics don't really work for that. If you know, this is from the... No, nein, das wollten wir nicht.
Sorry, no video.
So, this is not the time for the video, so sorry. So if you want to see the keynote from last year again, you have to do it online later on. But this is from the keynote last year, and this is what a simple heuristic actually did. You see the subtitle here, and it says, well, it kind of occurred to me in a telephone. And so, well, in a telephone what? So, and that doesn't make sense. But if you look at the whole sentence, you see that it occurred to me in a telephone call, and that makes much more sense. So you need to actually get the syntactic information that telephone and call are strongly related, and you don't, it's a bad idea to have a chunk boundary between those two words. Therefore, we perform a full syntactic analysis of each sentences that looks like this. This shows the dependence of well, each word to another word, and then you get a dependency tree. That's done by some nice program that does this, and it doesn't always get it right. So that means we have to take into account that it doesn't get it right all the time, especially because the sentences can be really long and there can be syntactic errors and so on. And then we just search for the best chunking, that is for the best split points in the sentence by defining two cost functions. First, by the splitting cost at each point, which says, well, if you split here, that will cost you 200 points. And if you split here, that's only 1 point. And the other cost function is the resulting chunk length. So if you have a chunk length of only 2 words, that's extremely bad. But if you have a chunk length of 200 words, that's also bad. You want to be somewhere in the middle. And with this, we actually get better subtitles. Yeah, our results show debug interface. Can you switch to that computer?
Who does that? Who's in charge of that? Should I press a button? That we should... no. We heard the no.
Okay.
No.
So what you can see here is just the debug output for our system, and it shows the dependency tree. I think the tree is not really that visible. So the gray-like parts over there, this is the dependency tree. It's perfectly clear for me, sorry. And then you can see the different chunks. And on the right, you can see all the meta information we added. So for example, when does this word, so the first here, the U, when does the word start? It's the word number 29, and the syntactic parent is word number 30, and so on, and so on, and so on. And so we use all this, and we can actually jump between points and see why the system actually does what it does. And that's important because we don't have a clear gold standard where we can say, well, this is wrong, this is right. We can only have a look at it as humans and say, well, this looks good. And if it doesn't look good, well, let's see why this might be the case. Yeah, and usually you would hear sound and I don't know what, but not today, sorry.
The sound is there, it's just not very loud.
Okay, if you want to switch back, that would be great. Yeah. Okay.
I think it's me talking now. It's
and we actually process, I don't know, several videos with it, and it mostly works, and we have to further work on this. And I think we'll go to this. Yes. Is this your part?
I think it would be, but you... Yeah.
Yeah, you can.
So to sum up those results, some statistics on last year's keynote. We have processed more videos than just this one. So is this the 5 minutes before the questions? Okay, good. Thank you. This is some statistic on last year's keynote. We get alignments for roughly 90% of the transcribed words. So that's not all the words, unfortunately. We have some ideas how to further improve it. Actually, we have a huge problem with applause, which is very disruptive, and laughter. So we have the problem with applause that the first words after applause, so thank you very much, the first few words after applause are usually not correctly transcribed. We know that from the data. We don't have any good applause model in our acoustic model because so far we didn't get applause. Now we've got no thanks, no need, no. Thank you. So far we didn't have any applause data, so we couldn't have it in our acoustic models. Now we have data with applause. We haven't really figured out where the applause is. We'll have to do some manual work on that. But this will help us to build better acoustic models that contain applause and to then further improve the transcriptions and subtitles, of course. Our current ideas are to kind of estimate the duration of those words that we don't know about. Again, for the statistics, most of the time it's very precise. Sometimes it's just totally odd. We don't have any precise numbers on that. I'm telling the students all the time that we need evaluation because we're doing scientific work. I can talk all day about that. But the semester isn't over yet. We have more ideas. We still need to improve chunking heuristics. Also, we want to go to two-line subtitles, which sounds like very dull, but it does change the game a little bit because now you have two different kinds of like chunk endings which need to be integrated. And then there are all sorts of practical issues. We haven't integrated with Amara yet in a suitable way. We had promised originally that we wanted to talk to process 31 C3 talks. We haven't done that. I apologize for that. But we're working on that, and some people actually need credit for this class, so it will happen, I promise. So for the other direction we were going for...
Yeah, it's you.
That.
No, yeah.
Oh, now I'm off? Well, whatever. So we also want to use this data that we got for better... Oh, kan je almost me guy. Now, language changes are also a difficulty in transcriptions. The cable behind the back? No, that's funny. Okay, now better? Now it's better, okay. We also want to use the data, as it's very freely licensed, to improve the open source speech recognition models that are out there. You need lots of data because all those models are usually machine learned. It's estimations on large amounts of data. And as Arne said earlier, that's a huge problem so far, and it's much improved already. And we hope to get another, 30 hours or so of speech data, of talk data into those acoustic models which are freely available at VoxForge. It will be German, it will mostly be it will be English, but mostly German-speaking English, so that will also be an advantage afterwards for the English models for German speakers. Yeah, so that's one of the goals that we have, where we think this is actually a perfect example where two sides actually gain something, actually three sides, because the students are learning something, C3 is getting transcriptions, and we are getting data. So to wrap up, alignment is simple for computers, hard for humans, and this is exactly the opposite for transcription, which is easy for humans, hard for computers. We combine the two for best results. Then subtitling is more than just alignment, because this splitting is actually very difficult. Yeah, thank you very much. Oh, no, thank you not very much yet. So we have plenty of ideas for future work, which also at least partly line up with the C3's ideas about subtitling. I really like the idea of having very low delay subtitles. So go from a few hours delay to a few seconds, that would be marvelous. And in that, we could use the typing speed information, because these transcriptions are actually made on Etherpads. We have like key by key timing information, and right now we're throwing this information all away. We're just saying, okay, it could have been transcribed whenever, but usually people transcribe in sequence and mostly during the talks. Thank you very much, whoever is transcribing or might be. Yeah. And we're throwing half of your information away, for the record. But we intend to change that and use this typing speed information for the transcription process. For the alignment process, sorry about that. Of course, if we didn't have talks, but more fantastic videos, we could do video analysis and all sorts of other things, which would be really nice to have kind of built an information retrieval, content search facility where you go to the video directly when you search for, I don't know what, something, say privacy or something. All right, thank you very much.
Thank you very much. We almost are completely out of time, and I wanted to ask whether the Signal Angel has one really pressing question from the internet, because all the other people, it would be so great if you could just ask directly so we can free the room again for the next talk. It would be so great.
Okay, then let's have one question from the internet. Did you test it with a normal movie and some transcription extracted out of some subtitles available?
No, we have not done that yet. We intend to do that, but as I said, not all, like our evaluation scripts aren't really done yet, so testing it on those data would be hard. I doubt that we would excel over like commercial services, but we're working in that direction at least.
Okay, as you go out, please don't speak, as other people are still here. And this was really fast, so we can do one other question. There's one at microphone 3.
Hi. Okay, so you fleetingly mentioned that the subtitles had to be readable, which means that they have to be displayed for a long enough period that people can actually have time to read them. And in classical subtitles softwares, what happens is you map subtitles yourself, and the software calculates for you and allows you to use a determined fixed number of characters. Are you going to do something like that, or do you just plan on going on some sort of gut feeling of what is readable and what is not? And if you are going to do that, are you going to have to actually adapt your transcriptions, which happens in translations? You can't actually keep the whole sentence. You actually have to focus on some part of it or not. And yeah, basically.
So first question, whether we intend to do more than karaoke. Yes, we do. Right now, we try to get as precise timings as we can, but then we have to think about the usability issue that we have to show a subtitle for a sufficient amount of time. Exactly, I haven't mentioned that, or we haven't mentioned that, but yes, we do intend to do that. It's like an additional constraint. Now, to your second idea of changing subtitles, so that perfectly makes sense for translations, I think, and is vital there. But we are trying to remain truthful to what the speaker said, or at least to what the transcriber transcribed, which may differ in those cases. So far, I think that's beyond the scope of this current little one-semester project, because we would need exactly the kind of understanding of what was going on in that sentence that we don't have in order to be able to shorten things.
Thank you so much, Arne and Tim. I think you will be over there on the outside to answer more and more questions. Thank you so much for that, and this is your applause.